Hello. In this lab, we'll be investigating charge on ordinary objects, and so we'll be modeling the combination of electric and gravitational forces acting on tape. In this experiment, we'll measure the force of repulsion between two charged tape strips using electric laws, such as Faraday's and Coulomb's, and in a model where the force of repulsion is balanced with the force of gravity. This is made through glow scripts to measure the electric force and the charge of each of these strips. So the physics principles which are integral to this experiment are the equation which solves for an electric field, as well as that for the force against particles with electric fields. And so also Newton's second law is used in order to solve for the force of gravity. And with these, we can determine magnitudes and the magnitudes of the charge. And so the lab is set up with each of the tape being 0.215 meters, and using this ratio of 1 grams per length of a meter, we have 2.15 times 10 to the negative 4 kilograms. And the distance between the top tape and the bottom tape is 0.015 meters. The acceleration of gravity, as always, is 9.81 kilograms meters per second squared. And so the characteristics of this whole lab is that when ripped off the non-sticky end of another tape laid on a smooth surface, a strip of tape attracts the positively and neutrally charged objects. When brought near another such charged strip, the two repel each other. So this means that both the tapes are negatively charged, and like charges repel each other. And so the model depicts more on this. The model assumes that there's no air resistance between the tapes, and that the top tape is treated as a point charge with all the charge being at the center, and both tapes are also assumed to have the same amount of atoms and the same charge, basically identical. And then the other tape has the same amount of charge which is evenly distributed along the tape. And so in the model, these values are shown, and the way these values are found is by using the equation for the electric force as shown earlier, and it's equated with the force of gravity in order to find this formula. And given our constants and the arrows depicting what's going on, we're also able to find the amount of excess electrons which act in the interaction, and then with the distance divided by this ratio length of the atom length, we get to find the amount of atoms, and thus the ratio of excess electrons to atoms, to show how much charge is given off. Now with this program running, we see what's going on. So you have this atom, this particle, this point charge acting as the other bit of tape, which is part of the surroundings, and then the rest of the surroundings is involved where the force of gravity is acting on it because it's on the Earth. And then this electric force is what's occurring on this particle due to this one. And as you see, both of the arrows have the same magnitude, and thus they cancel out, and the tape is in equilibrium. And here are the values of the things in question. Okay, so now for some discussion. So if the electrons had positive charge and the protons had negative, there wouldn't really be a big difference because the charges would redistribute as they would, and also the excess electrons with positive charge would just repel against the positive electrons of the other tape, because no matter what, if you have two positives, they repel, and two negatives, they repel with equal force. And so when handling the tape, it's always best to have our hands and other objects not get in contact with it due to the grounding effect. This is when the excess charge on the tape transfers to our hands and these other objects, thus limiting how much charge is going to interact with the other bit of tape. So contact should be limited so that the excess charge acts against the tape, and then we can properly measure out the force of repulsion. Okay, so that's it. Thank you.